Thank you again for attending the UC Berkeley Energy Symposium. We're going to start with our carbon neutral technologies ready for commercialization at Berkeley panel. Our moderator for this panel will be Paul Wright, Acting Director of Citrus. The other panelists will be Richard Halstead, the President and Chairman of Empire Magnetics. We have Nate Oda, the CTO of Aptility. And we have Michael Cohen, the Associate Director at the Office of Technology Licensing. So with no further ado, I will pass it off to Paul.
Thank you very much. I'm really delighted to be able to chair this panel. And as you saw from some of the opening remarks from David Sandelau and a couple of slides I showed, I think it's these carbon neutral areas of energy efficiency and so forth that's going to make the biggest attack in the shortest amount of time. In fact, sometimes I use this phrase, energy urgency. It sounds kind of cute. It's not alliteration quite, but it's close. But these are some of the urgent things I think we can do to both address the carbon problem and to get more energy. So without further ado, I'm going to invite our three speakers to give very short introductions to their work. And the first is you. Oh, sorry. First is Rick at the podium. So with great pleasure, I'd like to introduce our first speaker. And please give him a short round of applause to make him feel good at the podium. Thank you.
Am I on? There we go. First of all, thank you for inviting me. Secondly, I just flew in from Washington, D.C. last night, about midnight. So we didn't have time to shorten our slides to meet the format, and they've asked me to compress this. So I'm going to be really moving through this. I wear two hats. Empire Magnetics is a company that does specialty motors, including alternators, which gets into windmills. And we have created a collaboration we call WindSail. Next slide, please. Lawrence Berkeley Labs, in collaboration with a Russian group of the Makiev Design Bureau of the State Rocket Center in Russia, have been working together with Empire Magnetics to create a family of vertical axis windmills. Next. So what do rocket scientists know about windmills? Basically everything. If you think about the airfoils and all of the energy problems that go into building a rocket, the windmill is a piece of cake by comparison. One of the things I will compliment our government on doing is having the foresight to understand that having weapons of mass destruction scientists unemployed in this world is probably not a good idea. So we've been working hard to find some way to convert them into peaceful and useful activities. Next. Basically what we have is the equivalent of NASA designing a windmill for us. I'm talking 4,000 PhDs, wind tunnels, water tunnels, every kind of massive equipment you can possibly imagine. And we have come up with a very, very good technology, and we're at the edge of commercializing that now. We've got some prototypes, and we're working towards trying to make this into something that will generate energy for the world. Next. Trying to size the problem a little bit. This is a graph from ExxonMobil showing energy requirements and energy demand. If you look at the red part of the curve, this is what they predict they need to come up with in order to keep up with energy demand. Translating this roughly, we only need to find and develop the equivalent of 2 Saudi Arabias in order to meet this curve. Next slide. Bruce of the Lawrence Livermore Labs was trying to size the problem. And he says to keep pace with our population growth, even if you have a robust conservation program and you are investing heavily in new renewable energies, we still need to build the equivalent of a 1,000 megawatt power plant per day for the next 10 years. Now this is to basically keep us where we're at in terms of energy consumption on a global basis, accounting for population growth. So I don't care how big your windmills are, I don't care how many solar panels you build, how much ethanol, it's not enough. Next. So if we have this huge demand for energy, why hasn't wind and other renewable really taken off? I mean, why isn't there just a massive infusion into this area? The answers are governmental assistance, governmental tampering, governmental help in the marketplace. What we've really done is we've messed up the supply and demand chain, and I will go into these one by one. Otherwise, we can talk about this offline. There's all sorts of other indirect costs that are not accounted for, strip mining, pipelines, oil spills, it goes on and on and on. These things do not show up in your electric price, but they do show up in your taxes. The other side of it is, what is the value of clean air? What is the value of not having pollutants in your water, your acid rain, and all of those kinds of things? These things are not monetized, and so when you start to look at renewable energy as an investment, it's great socially, but it's not very good in a return on investment from a venture capital point of view. Next. It's not an accident that Denmark, selling electricity at 20.7 cents per kilowatt hour, is leading the way in renewable energy, while the USA at 8.9 cents is lagging behind. It's just simple math. If you're a businessman, you're going to go where the best return on investment is. Next. This is comparing large windmills and small windmills. One of the big problems that you have is the places where there are strong winds and they are in proximity to markets where electrical power is delivered are rare. People don't live where there are strong winds. When you throw out the cat and it doesn't come back, people don't like that. The power in the wind goes up as the cube of the wind speed. So every time you double the wind speed, you get 8 times as much power in the wind. People don't like to live in these places, but that's exactly where you put the big windmills. Now there are certain locations that are being built out very rapidly. Those things will be consumed very shortly, and then you have to start looking at alternatives. The one thing arguing in favor of other alternatives is the cost of building power lines across long stretches of land is many billions of dollars. So when you start including the cost of power lines in your equation, everything changes. Next. This was meant to show that people really don't live where there are winds. If you look at the overlay of population density versus wind, it's almost exclusively, you know, where the people are, there is no wind, and where there's wind, there's no people. This is just the local area. Here in San Francisco, Berkeley, Bay Area, you've got mostly class 2, maybe some class 3. The Cardenas Straits gets a class 4. Next. Another area that is impacting renewable energy, if we look at the cost of a typical small wind installation, only 20% of that cost is the turbine itself. If I work very, very diligently and I make the turbine for free, 80% of the cost still remains. What am I talking about? I'm talking about you dug a hole in the ground to pour concrete in, to put up a tower. You had to have an inspector. You had to have a professional engineer sign off on the plans. You had to have an electrician come in. The list of all these services and governmental agencies that get involved is long. A very significant portion of any renewable installation right now is governmental dictates and insurance dictates. Next. When it comes to permits, there are no national or even regional authority that you can go to. You can't say, here it is, I'll do whatever you want done, and then we can apply it across the board. What you have instead is a patch quilt of local agencies, governments, counties, cities. We tried to put a test windmill out on the coast. We wound up having to deal with Marin and the California Coastal Commission. They were talking 3 years to get to a permit for a 90-day test. Next. Of course, there's NIMBY. Nobody wants a big windmill in their backyard, no matter whether they make money off of it or not. One of the biggest problems we have is misapplication of information. Everybody is convinced that windmills kill birds. All windmills kill birds. It's a given. Well, I'm sorry. Birds die of old age and everything else. People have not gone out in the fields and looked for how many dead birds there are in a field where there are no windmills. They do look for dead birds around where the windmills are at. Long story, again, I don't have enough time to go into it, but our vertical axis windmills turn much slower. The birds can see them, they dodge them. We don't have any incidents that we know of where we're killing birds. Next. Another huge problem that is not recognized generally by the public is that they're not looking for a windmill. What they're looking for is a solution to an extremely complex energy problem. When you say, I want a windmill, what you're really saying is, I want to have electricity that is compatible with the grid, that meets the voltage, meets the frequencies, meets all the safety standards, and the list is long of all of the things that you really imply when you say you want this. It takes a huge team of people to solve these complex energy problems. Next. So why do we have a lack of investment in the renewable energy area? Well, a long history of government support to prices has depressed pricing. Therefore, you have a low return on investment. One of the things I would like to say, I just came back from Capitol Hill. President Bush is going to ask for another $100 billion for the Iraq War. If we had taken the dollars that have been spent on this war and allowed it to be collected in the form of higher energy prices, we probably wouldn't have a war in Iraq today, because we would be much more independent of our oil supplies. This war is actually a subsidy to our energy supplies. You may not see it that way, and if you want to argue, I'll be happy to talk to you about it, but it is my contention that it's true. Next slide. Venture capitalists are charged with making exceptional returns on investments. That means that only one in a few thousand business plans that they look at are actually going to get funded by them. And I'm not saying there's anything wrong with that. If I was in their place, I would do exactly what they are doing. But if you want to see renewable energy and you want to see alternative energies being funded, you have to look at how do we make these things turn into exceptional return on investments or find other ways to fund them. Next. Generally speaking, I've gone through a whole number of venture capitalists, about 70 of them now. They all have a pattern. They do 3 to 5 business deals a year. They're looking for outstanding rates of return. They have a 5 to 7 year time frame. They are not going to look at a small business that doesn't meet their models for making money. That's fine. Generally speaking, in doing my surveys, I found that they're funding about 1 out of 10,000 business plans that they look at, if you look at the filters over time. Yet, in our own government, we find that 92% of all new jobs are created in companies with less than 50 people. These are not the kinds of companies that the venture capital funds are putting money into. 85% of all new jobs are in companies with less than 20 people. So if you wanted to take an average, you could say that all of those 9,999 business plans that didn't get funded could have created something like 200,000 new local jobs. But they're never going to get a chance because they're not going to get this venture capital. Next slide. So the whole thing is, how do we monetize the benefits and the costs in order to make this make sense? In case you haven't noticed it, oil prices have gone up almost 300 and something percent. Natural gas is up about 230%. Our electric rates are up 30%. How is this possible? Well, one thing is a time lag. It takes time for the utilities to justify their rate increases. But I can sit here and predict with some great certainty that electric rates are going to go up, and they're going to go up very dramatically in the next couple of years. This is going to benefit renewable energy. You as the homeowner paying the electric bill may not like it, but it will generate revenues for renewables. Next. That's the end of my presentation.
We're going to move right along with the presentation so that Dr. Nate Oder is our next presenter. I don't think my microphone is on, but Nate is going to be our next speaker. And then we're going to get have questions afterwards, excuse me, and the discussion.
Good morning. It's a pleasure to be here and an honor to talk at the Berkeley conference. Can you put the first slide up? So I only have 5 slides. I'll be quick about this so we can get to some questions. Aptility is a smart grid company. We sell home area network solutions that support price responsiveness, energy efficiency, and behavior-based energy efficiency. Next slide. It's a very early startup. We're in an incubator right now. It addresses primarily the problem with heating and cooling in this country, targeting smart thermostats. Just to frame the challenge that Aptility is addressing with heating and cooling, the typical household spends about $700 a year on heating and cooling. Many of you probably spend a bit more than that. So it's a big hit to the consumer. Ties up a lot of money that could be spent elsewhere in the economy. If you look at the energy consumption that heating and cooling plays in the United States and for each household, it's very large. In the US, heating and cooling energy is about 1.5 times what Mexico uses in 1 year. And that's just to heat and cool homes. It doesn't account commercial and industrial. Environmentally, it's very expensive as well. The emissions related to heating and cooling homes, it's about 10,000 pounds of carbon dioxide emissions per year per house. That's roughly equivalent to what a passenger car is. And if you look at in aggregate in the US, that's 500 million metric tons a year just for heating and cooling homes. So that's a big, big part of the problem for global warming that can be addressed by smarter usage of energy. Heating and cooling also, particularly cooling, plays a big part in peak demand problems in this country. Many of you will recall the blackouts in 2001 in California, the 2003 blackouts in the Northeast, and there's many more blackouts that happen every year that you don't necessarily hear of in the news. Air conditioning is a big driver of this, and in California, it turns out about 50% of the additional peak demand on a hot summer day is from residential air conditioning. So what we need are technologies that are smarter, that use energy in a more clever way, that talk to the grid, that complement new supply-side sources. Next slide. So what the Aptility solution is, our first product is a comfort control solution for your home. It leverages wireless sensor network technology to enable smart thermostats that connect to utilities and other information sources. The basic scenario is the box of goodies comes with 4 or 5 wireless sensors. You would put one in each room to measure different conditions throughout your house, wirelessly communicate to your thermostat, wirelessly communicate to a little box that would talk to your internet router. The general concept here is twofold. One, the proliferation of ubiquitous sensing in your home enables much more sophisticated control. And second, communication. For decades, since the very first thermostat was invented, it's been an isolated item in your home. Information technology allows us to open communication channels to other entities in the supply chain, like utilities, and through communication standards, resolve some of the peak problem with demand response and enable more effective use of electricity. In particular, there's 4 high points with our technology, and the first 2 kind of go together, and it's a theme of what I think you will see on demand side clean tech innovation. It's the integration of energy efficiency and load management. And that's something new, that's a trend in policy, a trend in funding, and will be a trend in startups. So our technology is unique in that it provides both energy efficient operation by understanding kind of the metabolism of your home. Because we have ubiquitous sensing, we have a much better picture of what's actually going on, and we can leverage that to reduce energy consumption without trading off any comfort. Because our system communicates, we enable demand response. And at the most simple level, this is receiving a, oh my gosh, we're about ready to have a blackout signal from utility and resolving that. A big part of our technology, and what I think is important on the demand side, is enabling consumers to express their choice, their preferences for how much they want to spend versus what they want to get out of their systems. In this case, it's comfort. Some interesting, two more points here at the bottom. From the get-go, a big part of the demand-side solution, there's a term used by a lot of the policy makers called social equitability of technologies. That means that can everyone have this? Can you retrofit all the different buildings?
What was that word again?
Social equitability. So the idea that you can't classify technologies and deploy them for certain socioeconomic classes. This technology requires no new actuators. It can completely be retrofit to every home in California. And the last point here is the point about customer choice. Typically today, there's a disconnect in the way consumers consume electricity and how it's priced. And that's a fundamental flaw of the markets. If you know about the electricity industry, that's the disconnect between the wholesale and the retail prices. Actually, it was touched on in the previous talk. The objective here with this technology and what differentiates us from other kind of smart thermostat technologies is allowing the consumer to set their comfort and cost preferences. And that is a big part of what demand response is all about, allowing consumers to set their preferences. So next slide. Quickly here, in being a company that sells sustainable products and carbon neutral products, it behooves us to make sure that our product is itself sustainable. So in fact, what this slide shows, and we've done some back of the envelope calculations, essentially we go into debt environmentally making products. So making a thermostat, making the silicon, assembling, transportation, et cetera. The energy savings should pay off the environmental debt. And doing a quick calculation, we have a break-even time of about 2 years for our product, so that's good news. Without going into details, I think it's important just because we're talking about carbon neutral technologies and policies that this type of analysis should be incorporated into startup companies that evaluate the total environmental net impact of what you're trying to do. And one last slide just to provide some talking points to kind of gear you guys up to asking questions. Today, what's called demand response is an effort by utilities, by government, to effectively enable time variable pricing of electricity. That's called demand response. So there's a technology part that says you need automation to respond to price signals that are sent from utilities to end users. A big part of demand response is in standardizing the way information is communicated about electricity price, standardizing communication channels, back-end infrastructure. What's unique and what I see the future holding with startups, with carbon neutral technologies, is leveraging the efforts today by people developing standards for demand response to enable sustainable consumer choice, especially with things that go into your home, like what Utility sells. So the scenario in 5 years is that every home will have this type of communication, be it smart meters, smart thermostats, or other communicating devices. The same APIs and communications that we can value electricity from a coal plant today can be used to value the carbon output of the electricity you get from a PV plant or a hydro plant. Allow consumers to have that information in real time, make decisions on how they use energy based on that information. The next challenge coming down the line is water. The same APIs can be used to value water, to let consumers have the choice through technology in their home to determine how they use natural resources. And the same APIs can be applied to network level or neighborhood level aggregation, many people working together to resolve issues. And then the blue box in the bottom left, there's a growing number of sensors embedded in the natural world, measuring things like cubic feet per minute of a river flow, particulate matter in the air in the city. What this is allowing consumers to do, that sets the stage for closed-loop control between how you use electricity in your home and the impacts it will have on the environment where you live. So there's sensor networks in the world that do that. There's sensor networks on your meters. There's sensor networks in your home. Going forward, I think you'll see standard APIs connecting systems of systems and enabling much greater consumer choice about how we use energy. And with that, I'll turn it over to the moderator. Thank you.
Very good. Our last speaker actually is a very valuable member of this whole community. Michael Cohen is the marriage broker between many of the projects that begin at Berkeley and many of the companies that start in the local community. And so it's a great honor for us to have him with us today. And even if today you can't quite get connected with him, please get his card and his email address and use him as a person who's an enormous resource on the Berkeley campus as one of our key technology drivers and technology bridging people. Thank you, Mike.
Well, thanks, Paul. I've done a lot of weddings for Paul and his students, so thanks for that introduction. There is just a huge amount of research, know-how, and intellectual property coming out of Berkeley, as well as LBL, and the rising star is renewable energy and green technology. So what I want to do over the next few minutes is just summarize and highlight some of the fundamentals of commercializing technology at Berkeley. And those fundamentals are just clarifying our objectives, summarizing our methods, our philosophy, and finally just an overview of our process. And I think if you just understand these fundamentals, it'll be so much easier for you to work with the university. So let's start with objectives. I practically start all of my conversations with startups and companies that want to commercialize technology with just clarifying our objectives. It's not about just making money. It's about establishing relationships as well as agreements that really compel our technology out there fast and broadly. And we do that for the benefit of society as a public institution. We do that to support the research and educational mission of the university. And also we do that to reward the inventors, like Nate and Paul, for their ingenuity in coming out with this great stuff. So let's now move to the methods. At traditional universities, the method of commercializing technology is simply referred to as tech transfer, and we do that really well at Berkeley. You know, there's tons of papers published in journals and presented at conferences, and students are hired all the time, and faculty consult for a lot of companies, and that's just the traditional types of tech transfer. But at Berkeley and a few other progressive institutions, we don't just try to transfer technology, we try to catalyze the commercialization of technology. And here's how we do it. Here's our primary method. If you look at the research coming out of Berkeley, you could characterize it along two dimensions. Along the x-axis, you can talk about the risk required in the investment to try to commercialize the technology. And on the y-axis, you could characterize it as the potential return on that investment. So now if you look at Berkeley, UC Berkeley is a research institution. We're not an engineering company. So not surprisingly, a lot of the research that comes out of the university is very early stage. Very exciting, but very early stage and unproven. And so a lot of the Berkeley technologies on the far right corner there, high risk, takes a lot of time and a lot of money to turn that from lab scale into something that's commercializable. And even then, you got to wonder whether it's going to be competitive with other technologies and actually be a very successful business. So it's very risky to commercialize technology from universities. And in order to get companies to try to do this, companies, small and large, as well as venture capitalists, there's got to be an interesting return on investment. And so if not for, so our challenge is to try to get those orphan technologies at Berkeley commercialized. And one of our primary methods for doing this is, for example, on the corner there, is to take a technology and enable a company to get a competitive advantage over any other companies that would try to follow them in commercializing the technology. And likewise, we can also on the lower left corner, help companies assure them that they have the freedom to operate so they won't be sued for infringement, and that would lower the risk of the investment. So in doing those two things, we can make this a better return on investment and turn orphan technologies into commercializable technologies. So now, let's talk about the philosophy at Berkeley. I would say that Berkeley and a few other universities across the nation are very progressive in our approach, because the traditional way to commercialize technology at universities is to just license it. And most universities have considered that to be simply a transaction with a company. It's about the money, it's about the terms. But at Berkeley, we have a different philosophy. We really believe in a relationship, not just a transaction. And so you'll find that when you talk to us, we're always looking for opportunities to do research collaboration, as well as commercialization partnerships, and finally also the transaction of licensing intellectual property. Okay, let me just say a few words about the process. Our process at Berkeley is all about managing the risk. And that's where a lot of these startups and a lot of the new technology is about, managing the challenge of moving up the risk curve and making it successful. So you'll see that we've established an iterative process that allows companies and investment firms to allow their commitment with the university to be commensurate with the risk. So early on, if the risk is quite large in terms of the potential of the technology, the market opportunity, even the value of the patent rights, we can set very low commitment levels so that you can lock up the IP and keep moving along. And then finally, if you really feel confident about launching these products and technologies, then we can establish full license agreements with royalty rates and so forth. So that's our iterative process for managing risk with companies, and it's quite successful. So in summary, let me just emphasize the key points here. At Berkeley, it's not just about transferring technology. We try to catalyze it as much as possible. And our focus with companies and entrepreneurs and venture capitalists is about the multifaceted relationship. It's about sponsored research, hiring students, getting startups going, not just about the license transaction. And if you have any other questions, you can, offline, you can see me or go to our website and take it from there. Thanks.
Very good, thank you. So to make this as interactive as possible, can we have some nice questions from the floor, please? Yes, please. Thank you. I think there might be a microphone to go. Oh, here we go. Ben has one, just to make it clear. Is this being recorded, Ben? It is, okay. Thank you.
This question's for Nate. I was curious about the APIs that you mentioned. Has Aptivity come up with a standard set of APIs for communicating with these sensors at utility companies and other, players?
Is this on? Can you hear me? Okay.
Yes.
We are actively working on developing APIs and standards and involved in several efforts on this. The cold hard facts for demand response in particular, it's a moving target. DR is such a new concept for California, let alone the US, that it hasn't been solidified into a common standard, which has actually been a big hindrance for DR taking off. There is no federal mandate that says this is how you communicate electricity price signals to consumers. Like the issues faced in wind power with the local and regional patchwork that was referred to, the same thing is with DR. And that's been a hindrance for DR taking off. One effort in particular is led by Marianne Piet at LBNL to do standard information for DR, and I would recommend looking at her work for that. But it's a moving target for APIs. The potential is that you could use the APIs for extensibility to different applications to enable consumer choice.
Actually, I have a semi-related question on wind power, if I may ask. I mean, is there anything in the Title 24 horizon for encouraging the connection? It's not an API, obviously, but connection to the grid from your perspective?
I am not aware of anything. Is this on?
Yeah.
I'm not aware of anything specific at this point, but I do know the American Wind Energy Association and the Department of Energy are both working towards trying to make a standard whereby we can come up with a grid-tied inverter, basically trying to simplify the problem of connecting to the electrical utility.
What was the problem with the Marin County 3-year running slow start?
The bottom line is it's Marin County, but what we were attempting to do is put a small windmill out on the coast for a 90-day test. And in order to do that, you have to have a permit. Well, when we went to Marin County, they said it will take 18 months and we'll need $25,000, and there will be at least 3 public hearings. And when you get done with that, then you have to go to the California Coastal Commission, and they will have to go through their whole process. This is all to put up one small windmill for a 90-day test.
I see. Okay. Any other questions from the floor? Yes, there's lots of questions. That's good.
Thank you. It's kind of a follow-on question in a way, coming from Richard Halstead's comments about wind energy, but you've nicely profiled a lot of these challenges that you face as a small business. I'm just wondering, when you look more globally, across the Scandinavian countries, perhaps other countries that maybe are further ahead in wind power, or even any of these interesting ways of conserving and managing energy better, do you see some great opportunities for collaboration over there? Or is the society and the culture so drastically different related to the solutions that they just don't relate very well to the U.S. environment?
You're asking about international collaboration on these types of projects. I was in Helsinki, Finland. They have an equivalent national lab there. They are supporting wind power with national funds. The Chinese in particular are being very aggressive about wind power. They have specific goals of how much wind power. Shanshan down here might actually know the numbers. She's been working on that market research. What I'm seeing as a general pattern is that the U.S. is probably the most difficult market in which to install small wind energy systems. The rest of the world is much more friendly. That answer your question?
It's a disappointing answer, but I think it answers the question. Yes, back there.
Yeah, I have a couple of questions for Rick Halstead. Despite what Paul just said, we do have a renewable portfolio standard here in California, and we're trying to achieve 20% renewables in energy by 2017, and wind is the most cost-effective of the renewable technologies that we're looking at. But there are two problems that I'd like you to comment on, Rick. First, the wind blows at night and our peak periods are during the day. To what extent do you believe that the efficient utilization of wind resources depends on a correlative development of electricity storage technologies?
That's
so
a good question.
The first question. Second question has to do with cost. We have, you were concerned that electricity prices are too low. We have in California market price referent. We look at combined cycle, efficient combined cycle as the benchmark. If the wind energy can come in below that $90-some per megawatt hour, then it's presumed reasonable. To what extent do you believe that the problems commercializing and making greater use of renewable energy can be resolved by having some kind of a carbon adder added to this market price referent? And what degree do you think that carbon adder should be? I mean, how many dollars per ton of a carbon adder do you think would be reasonable or necessary to really push renewables in the way we want to push them?
These are excellent questions, both on the storage and then on the carbon price.
Right.
Yeah.
Actually, there are three things here. First, a comment on the California Energy Subsidy Program, if you will. Yes, they did pass a program, And the law sounded real good when the headlines came out. However, the amount of money that they funded it with was very small, and the monies were consumed within a few months of having implemented the program. Now, moving on to the, what was the second point?
The carbon adder or the energy storage?
The energy storage. It's called in the parlance of the industry intermittency. And yes, it is a huge problem, and I just happen to be working on a solution for it. Let me back up just a little bit. Hydrogen is a scalable energy technology, and it is suitable for energy storage and the intermittency issue here. What we're proposing to do is use wind and solar power to electrolyze water into hydrogen and oxygen, store the hydrogen and oxygen, reburn the hydrogen and oxygen to give you power on demand, which makes your intermittent power source reliable. The output is steam. If you cool the steam, you get your water back. One of the key technologies is the storage of the hydrogen. Up until now, you've had to compress the hydrogen at high pressure, which is very inefficient energy-wise, or you had to cryogenically cool it, which is also very inefficient energy-wise. Turns out that my former roommate has a patent on a new liquid where you covalently bond the hydrogen into the equivalent of diesel fuel, and you can add and strip it back out as you want to keep using the liquid as an energy storage medium, not as a fuel itself. So we believe that we can solve the intermittency problem using this technology. Now, we are also looking at the efficiency of the electrolysis program. The former Soviet institutes have several electrolysis technologies using membranes, and they are very familiar with dealing with hydrogen because they were using hydrogen to fuel the rockets. So that, I believe, is a viable approach. We can use this liquid to store the hydrogen not only as a storage method on site, but you can actually transport the liquid in standard pipelines, standard trucks. We can even deliver the liquid to your local gas station. All they need is a small device to pull the hydrogen out. Now, with respect to carbon and carbon credits, it is an effective means of monetizing these benefits and costs that I was talking about. I must admit that I am not expert enough to tell you how much that should be. I think that's something that the marketplace has to determine in the long run, but I do believe it's a viable approach. Answer your question?
Very good.
I had some follow-on comment. Two great questions, and I think Richard did provide some great insight on that. With the peak power in wind, one option is to do storage, and I think down the line that will be a part of the portfolio for dealing with the temporal nature of renewables. Just last week, Texas had major blackouts because a cold front came through, killed all the wind, and stopped all the wind generation. They had massive blackouts. Another way to help address the temporal nature is to have smart systems like what Aptility provides. Systems that can connect up to supply and respond, be demand responsive when that load changes. Just a comment on the carbon adder for renewable subsidies. My experience has been more in the PV, and particularly how the subsidies in California particularly have been going down and down and down because they've been reaching milestones, which is a great thing for PV. The challenge is that makes it much harder for consumers to justify purchasing a PV system because the subsidies are going away. The other catch with that is net metering. The only way PV works for consumers is because they get a 2-to-1 or 3-to-1 ratio from net metering, so they can generate during the day and get 3 times as much payback at night. I think subsidies, whether they're upfront or whether they get wrapped into how you do electricity pricing. I think both are important and both play a role in how we value using energy in the future.
Another question.
Sure. So some of the stuff we heard about how difficult it is to make this work economically with the wind, where you have it takes so long to do your licensing, and with this demand response also you were talking about. I mean, it's in no one's short-term interest. Some people end up paying more, some pay less. From a business standpoint, where are the low-hanging fruit to actually roll this stuff out without having to do so much coordination and to make these rules change?
Well, I think speaking in general about energy efficiency in buildings, low-hanging fruit today is light bulbs, CFLs, and they get a lot of attention from energy efficiency rebates. That's as simple as changing something in and out. What systems that communicate provide, it's a way forward to do more effective use of electricity, and I think you'll see some of the barriers start to come down for DR and smart meter and advanced meter infrastructure because you'll see infrastructure being deployed. So all 3 utilities in California have been approved, if not already started their rollout of system-wide smart meters. Once that infrastructure is in and provides open communications to other technologies that communicate, that drastically reduces the marginal cost of different devices going into a home because the smart meter's there, the installation's been there. So I think part of the answer to your question is that you'll see some of the barriers for at least communication technology advances like DR technology begin to come down in the next 5 years or so.
Next question from the floor. Let's turn over. Oh, sorry. Carry on. Sorry.
Actually, question and a comment. I don't really think that building another industry on subsidies is really the way forward. And when you're actually going into some of the frequently quoted McKinsey study, points out that a number of sectors, in particular building insulation, for instance, are easily paying for themselves. So coming from that corner and assuming that we need to subsidize clean energies and so forth, I don't think that there is any study that really will be able to demonstrate that that is a way forward for public policy, with all due respect. More specifically, the question that I had for Michael Cohen is, one of the issues that the biotech industry is facing in licensing with the technology office of the University of California system is that you first have to go through the university campus system, and then you're going through the UC Regent system in Oakland, which makes it probably the least desirable office of technology transfer that any industry wants to deal with. And that's a quote from Pfizer. How are you able to cut down on that process and to actually making this commercialization process work, that there are not so many layers of administration? And we just heard how the layers of administration are increasing the cost horrendously.
Good question. I can't speak to every campus of the University of California. I can only focus on UC Berkeley. I can tell you definitively that at Berkeley, we don't rely on the Office of the President, Office of Technology Transfer to execute our licensing transactions for intellectual property. We sometimes refer to them for expertise, but maybe some other smaller campuses or campuses that have different protocols.
My name is Caroline Webb, and I'm a graduate student in San Francisco at the California Institute of Integral Studies. I've got a particular interest in energy, and that's why I'm here. Still very ignorant about the, but as an amateur.
So, I don't know where that came from, but I thought UCF had a comment about this. Anyways, so let me just say that at Berkeley, we pride ourselves on working at the speed of business. And I could say that with most of the stuff that we've done in the last several years, we are not the critical path to getting IP agreements completed. It's the companies, the company working with their attorneys or with their investors that needs to assess the agreements. But we turn over our side of the agreements very quickly, and as I said, we don't rely on a third party or another office of bureaucracy to get these things done. So, did I answer your question? Correct.
Some more questions, either phantom questions or real questions are most welcome. This gentleman here, and then I'll go to the bank. Ben, do you have a... Oh, how do we want to do this? Sorry. It's just here.
Thanks. What's your opinion of tethered systems? You know, the main problem with wind on the surface is it's intermittent, and there's not that much energy available for it. But right above us in the jet, it's what, 10 times more energy available. So what do you think of that, and how realistic do you think it is, and how long do you think it would take to happen?
You're asking me if we can test or tap into the jet stream?
Well, the flying rotor systems, you know, that would be in fleets tethered, you know, in the jet stream.
Well, it may be technically feasible, but I think there's some enormous problems to overcome. You might find that the airlines are not real receptive to having tethers in the jet stream where they fly their jets through. I did work on a proposal with NASA where they wanted to put a satellite in orbit and drop the tether down so they could deploy solar panels up in space and then literally run the power down the wire. There are some enormous technical problems with that, but they're at least looking at it. I don't think you're going to see jet stream wind energy real soon. It may happen, but I wouldn't count on it, at least not in my lifetime. Next. There's somebody way in the back there.
Yeah.
Test. This is a question for Michael Cohen. Can you provide some examples of the most exciting technologies, energy technologies that have come out of Berkeley, in your view, that have made it all the way through the licensing process? And also maybe touch on how quickly those companies were able to commercialize Berkeley technology.
Sure. For the sake of time, let me just highlight two, I think, that come to mind. One is in the area of solar photovoltaics. Research at Berkeley developed innovative ways to create photovoltaics out of what's called dirty silicon, because, and that solves the problem, I don't know if you're aware of that, these days a lot of the photovoltaic economics are driven now by the supply side, the fact that demand is outstripping supply for some types of photovoltaics. And so this company called Cali Solar spun out of Berkeley, and with the help of the faculty as well as some great entrepreneurs from the semiconductor industry. And we did that agreement, I think, this big intellectual property agreement in about a month. And I think most of that time was spent on their side, just working through the understanding of the terms. And then that company was funded by a top-tier venture capital firm to the tune of about $9 million. And there was talk about building a plant in the Bay Area, one of the first big solar photovoltaic plants here. But then that got a little detour because it turns out the German government was going to fund some of this through one of the German universities. So a lot of that research is now underway in both Silicon Valley here, the Bay Area here, and also in Germany. That's one example. Another example that kind of interesting to highlight here is with a company called XL Tech Group. They are commercializing algae-based transportation fuels, using algae to produce these transportation fuels, in particular isoprene. And the way that they did it was through Berkeley research that tweaked the genome of certain types of algae to make it a lighter shade of green. And that little change, you'd be surprised, what it does is it allows the sun to penetrate the algae biomass much deeper. And that, it's all about economics, it's all about efficiency of that biomass, and that allowed this kind of technology to become potentially economical. So that company, XL Tech Group, the interesting thing about that is, we not only did an IP agreement with them very expeditiously, but we also did a big sponsored research agreement with them, so that they're funneling their investment money back into the university with Professor Tassios Melis's lab to not only further that research, but also to hire grad students and really achieve the big mission of the university, which is scholarship. So those are two examples of fast-moving, very exciting, high-potential technology in the green tech space.
That was a nice response. Another question from the floor. We're getting some good questions. Yes, you're a long walk from a microphone. We'll just hang on. It's coming. This is like that TV show when you have to run down and get your prize, whatever it's called.
I am curious what resources are available for emerging green entrepreneurs at Berkeley, particularly collaboration between different schools. For example, Nate, you mentioned you're in an incubator. Is that a specific green incubator at Berkeley, or?
Sure, that's a nice question. Mention Vertex too.
So the incubator is not necessarily green. It's hosted by the business school here. We share it with 4 or 5 other companies at any given time, and they range from social networking sites to advertising, digital advertising. So it's all over the map.
Basement of the Bancroft Hotel.
Yeah, the luxurious basement of the Bancroft Hotel is where the incubator is. But it's free. It gets you on your feet. It gets you going. It is an indispensable resource that Dave Sharon from Berkeley has set up. In terms of collaboration, green entrepreneurs tend to self-select and find the groups that help them out. Berk is a great one. More generally, there's groups like the Entrepreneur Association out of Haas, which are, goes anything from real estate investments to green tech. In terms of cross-campus, I don't have a lot of personal experience, although friends of mine who are in the biosciences and kind of biofuels, I know they have collaborations with UCSF and different campuses like that. But in terms of what I've done, it's been primarily Berkeley.
Nice answer. I think as Michael, I'll leave Michael to be the cleanup hitter too on this question since we're getting close. Michael, you have some things you wanted to add here.
Right, that's a good question. And let me just highlight something that I've seen over the last several years, a phenomenon in that, first let me say that there are about a half dozen common approaches to how Berkeley is spun out, technology is spun out of Berkeley, but the thing that's really grown over the last several years is this phenomenon related to business plan competitions. Every year now, business MBAs scour the campus for technology that they can either use to fulfill some business plan requirements for certain courses, or to enter into the business plan competition, not only at the Berkeley campus, but across the country. And that is really driving a very impressive connection between business people and technology people, both in the engineering and science areas. And it's also not even recently bringing in law students. So that's a good example of how infrastructure drives this kind of team building, which then drives all these technology spin-outs.
Very nice. So what I'd like to do, I think our panelists are going to wait here for some personal questions. I did actually want to thank Ben Biddle and Chris Harders, who are still in the room, I think. Here they are, over here. They were the folks that organized this session, and I think we owe them a nice round of applause for doing that. Thank you. And then, of course, with Rick Halstead that spoke first, Nate Oter, and Michael Cohen. Let's give them a nice round of applause for their work. Thank you. So with that, let me leave people to come up and chat with our distinguished panelists, and thank you very much for attending, and I'll see you all at lunch. Thank you.